I hope my screen is visible to you all.
Yes.
Sure.
Yes, sir.
So, and I hope that my PPT is also visible to you now, and I'm putting it into the slideshow mode. Anybody can just give me a green signal so that we can begin. Hello.
Yes, it is perfectly working.
Sure. So, if at any moment I would request all of you humbly, because I have joined from my mobile. So, if anybody finds any problem in audio or any problem in the PPT, you can interrupt me at the very moment, and I will keep on speaking from the other system from which I have joined. So, welcome all. And first of all, this is Amritanshu Vajpayee, and I greet you on this August occasion in the month of July, okay, on the August occasion in the month of July of International Moon Day 2023, as we celebrate one of the greatest trysts of humankind with the destiny, that is today was the day of the moon landing. आज ही के दिन हमारा मून चंद्रमा के ऊपर पहला कदम पड़ने का सौभाग्य मानव जाति को प्राप्त हुआ था. So this is a small introduction of the day, and in commemoration of that day, United Nations has started celebrating the International Moon Day. So you may be wondering what this title slide reads. And actually, and frankly speaking, if you see, there are three portions to this slide. Portion number one is definitely in the middle, which is moon, our Chanda Mama. And the portion number two is the citizen science. And portion number three is something that you may have seen, sky. Rest of all is, you can say, a certain part of an attracting cliche that I have added to it. The reason is very simple. If you see any film today, we all are, you can say, filmoholics, cinemaholics. In the age of internet sharp connectivity, we all are netizens. So we do always search for something which is known as X factor. That certain project is successful because that certain thing was the X factor in that particular project. That certain film or became a blockbuster because of that X factor. So on the trending line, interestingly, our sky has got something which is known as M factor. M stands for the moon. So I welcome you all, and let's go on to this small journey of doing science as a citizen. Because as I always maintain in all my dialogues, that within each citizen resides a scientist, whilst each scientist is a citizen somewhere. So maintaining that equivocal balance, today I have chosen this day, and I thank wholeheartedly the organizers of this webinar and my collaborators, Shri Shobhanacharya ji of SS Citizen Science Group, for having given me this opportunity to speak to you all. So this is a small synopsis of the entire project that we will be looking at. I will be introducing you to the moon from a different lens, not that rhetoric that we study that moon has got this much radius, 1/4 of the earth, the gravity is 1/6 of the earth. Today we are not going to explore moon from that part. We will explore it something which is known as in a different manner. We will see the moon but little differently. Then we will move towards that citizen science, that is the crux of the talk of the day, that what actually citizen science means, and in astronomy what is the importance of citizen science. And then slowly we will migrate definitely to the moon, that how moon fares in the field of citizen science, and we will have a cursory glance at the different projects which are associated with the moon, as citizens, as amateurs, as you can say knowledge enthusiasts, and of course the challenges and the road ahead. You may be wondering, I have talked about moon, I am talking about moon, but have put the globe, you can say, or an image of the earth on the left side of this particular slide. You may be wondering, what is this? Trying to look into the sky and showing us the picture of the earth. Definitely, because we always need to keep our foot on ground. So we will be exploring the moon. That is that step which you can see rightwards. That was the step of the Buzz Aldrin, courtesy to NASA. This is images, and that step was genuinely photographed and planted on the moon by the second person who sat his foot over the moon after Neil Armstrong. Definitely, because as a part of the experiment to look for what were the characteristics and properties of the soils of the moon, like density, flavor, and all those things. And definitely, while looking over the moon, we should not forget our Earth, we being the Earthlings. So, and all the projects that we are talking about, it will be Earth-bound, moon-looking towards projects. So that is why a balancing act between Earth and Moon that I have tried to put it up here. Now coming to the interesting facts. You see Apollo landing on the moon, a cartoon rendition from Creative Commons. So let us now familiarize ourselves with the moon in a different pattern. You see, forget about that radius and everything. Let us, you can say, develop a little bit of curiosity towards the moon in another format. That moon is the second densest satellite after what? After Jupiter's satellite. Jupiter has got 4 moons that were seen by Galileo, and I am giving it as an assignment to you all that you can browse for it, that which is the densest satellite that precedes moon in the terms of density of overall things. And of course, the fifth largest moon in the solar system, that is our solar system I am talking about. These days we have to be very precise on a lighter note, because in the days of the exoplanet discovery, solar system is also not limited to the our solar system. Then secondly, moon is drifting away from the moon, from our earth. And you know, not simply drifting away, it is drifting at a very rapid rate, at the rate of 3.8 centimeters per year. 3.8 सेंटीमीटर प्रति वर्ष की दर से चंद्रमा हमसे दूर जा रहा है. And you know, if we go back in time, let us travel back in time, bring moon towards us at the rate of 3.8 centimeter per year, then you know an estimation comes that moon was about, if you just look at the half of the age of the entire solar system, about 2.46 billion years ago, the moon was about 60,000 kilometers closer to us. And you know, at that time, there was 17 hours of sunlight. Imagine what would be the days be like. So, isn't moon interesting? Isn't the proximity of moon worth going for? Then, of course, there is water on the moon, which Sumitji will be talking about in his presentation. Yes, of course. Then one more interesting factor. See, we see slightly more than half of the moon from the earth, about 60% of the moon. You know, moon has got, in the first slide itself, when we saw that opening title remark, there was a photograph of the moon revolving around the earth while earth was revolving around the sun. You may have seen the orbit of the moon was tilted, and yes, of course, what happened was it was in itself an elliptical orbit in totality. So, you know, the rate of the revolution of the moon, I will just give you a scientific fact. The rate of the revolution of the moon, we say, is almost equal to the rate of the rotation of the moon on its own axis, and revolution around the earth I am talking about. That is why a synchronization is maintained and we never get back to see the other side of the moon. But you know, the rate of the revolution is not uniform like the rate of the rotation. So, you know, we see around the edge of the each limb from time to time. So what that is known as there is a scientific term, a jargon that I will say, that is known as the libration of the longitude of the moon. So because of that effect, we see slightly more than 50% of the moon. Had it been exact, then the far side of the moon would have been 50% that we never see. But approximately 41% of the moon we never see. 59% of the moon, or almost 60% of the moon, is seen by us time and again. Then one more interesting factor. See, I am trying to build your curiosity into the features of the moon, that why study moon. See, the first quarter, you see, if the full moon, Purnamasi ka Chand or Purnamasi Chandrama, is the brightest of the moon. The full moon is the phase of the moon as the fullest, it's the brightest. But have you ever imagined the first quarter or the last quarter of the moon is not even half as bright as the full moon? And definitely it should be half, because it is the half phase of the moon. But you know, had it being a smooth surface like a ping pong ball or a tennis ball or like a cricket ball, shiny, smooth, bright, then the first or the last quarter would have been exactly half bright as the full moon. But you know, because of the rough topography of the moon, which needs to be studied, especially along the day-night line, which is known as the terminator line, when we study the moon, that needs to be studied to understand this. And I will give you one more cool statistics. that the first quarter of the moon is almost 1/11th of the brightness of the entire full moon. So you just imagine, not half but 1/11th. And even the 90%, 95% of the illuminated moon, that is before the full moon, just go behind 2 days, 2 days beyond the full moon. If you are a keen observer of the moon, if you start seeing the growing phase of the moon each day, you will observe that even 2 days before the full moon, or Purnamasi that we say in India, the moon is about 95%. Sorry, that 95% illumination is almost as half bright as the full moon. Observe it carefully. Naked eye observation, definitely it is. You can observe it. Even though no man is perfect, but practice still makes you perfect. And one of these peculiar, you can say, explanations, that moon has it got its own time zone. When you may have got this message of this particular meeting, you may have seen that it was somewhere in Indian Standard Time, 7 o'clock, and one UTC was also mentioned, that is universal time was there. Similarly, we have got different time zones. The earth has been divided into the different longitudes, about separated by 15 degrees, with Greenwich meridian being the standard time zone. Towards the left and the eastern part of the hemisphere is divided by GMT. Moon was given its own time by a scientist from New York Planetarium, was Kenneth Franklin, and he designed a watch for the moonwalkers. And what he did was, he separated the moon longitudes by 12 degrees in comparison to the 15 degrees as on the surface of the earth. And what he did was, period to rotate and revolve around the sun, around the earth for that particular moon, he called it one lunation. And on the basis of that lunation, he defined lunar mean solar time. Then accordingly, as we have 1 hour on the earth, minute and second, similarly on the watch of the moon, he defined one lunar, one decilunar, one centilunar. Like that, the time was being decided. So you see how interesting are the factors of the moon. And most interestingly, there are 4 different varieties of the lunar month, depending upon how we measure the revolution of the moon around the earth. Whether we mention it from perigee to perigee, whether we measure the revolution of the moon around the earth from one nodal point to another nodal point, whether we whether we are taking the reference as revolution of the moon from with respect to one particular star, or whether with respect to the sun. Accordingly, the length of the different months will differ. So these are all the factors that make that make our moon interesting, or the lunar surface interesting. That is why the exploration is needed. So I hope that today you may have seen the moon in a new light, and I hope that this light ignites in you the flame for something that follows in the next slide, which is the citizen science in the field of astronomy. These all are, you can say, the theoretical thing that I have written. But practically speaking, you can take a screenshot of this slide and you can keep on reading it. But as an interactive person, I will just like to tell you, see, the quantum of the scientists or the people who are professionals in a particular field is limited, and the data that flows in the day of the modern rocket science, in the age of the supercomputers, it is immense. Petabytes and terabytes of data is there that needs to be analyzed. So there is the need of the vigilant people who are adept to the collection techniques of the data collection, analysis, and interpretation to help solve the scientific research pursuit. So, in that sense, this is the field which is known as citizen science. As a citizen, you can contribute to the field of professional science while working at the amateur level, or at the level of a trainee, or at the level of a science communicator, or at the popular level. Similarly, in the field of moon, when you take the moon as a task, there are different n number of varieties of tasks which could be available. As I have just told you, about 59% of the moon surface we see, the rate of the revolution of the moon is not constant as compared to the rate of the rotation on its own axis. Then you see, I have just told you that how dim or how bright the different phases of the moon are in comparison to the expected one. As we say, the surface of the moon is not perfectly spherical. There are topographic differences are there, hills, valleys, everything is there. So shadow comes, but there is something known as mathematics, yeah. So we can mathematicize it. We can take it in terms of, you can say, statistics also. How can it be taken? By closely observing the moon. Observing, not simply like taking the mobile and going out and taking the photograph. That is another form of, you can say, cultural astronomy. But we can slowly dive deep into the field of science by taking moon as an instrumentational tool. Moon can be a great stepping stone. You can I just would give an example of a project that closed, that was Moon Zoo. And in that Moon Zoo, the participants, they used to identify and classify the crater taken by the NASA's LRO, that I have written in this slide also. And that helped to create a comprehensive map of the moon surface. See, in this world of approximations, the more and more we observe, the more we come closer to the accuracy. The precision increases. So that is why it could be utilized for researchers for the future study, because we definitely are finding an alternative place, or you can say a second place, for a perfect human settlement like that. And also, the resources on the mother earth are limited, but the human wants are unlimited. So we are trying to tap for the other regions where probably the resources could be available. So moon can definitely be one of those places, and citizen science in this manner really can work wonders. So it's not scientific community, but I am addressing to you all, us all, that just as we say in our preamble of Indian Constitution, we the people of India. Similarly, we the people who are present on this over earth, we the general public, we should participate, we should come forward, try to think out, try to map out the different features of the moon by keen observation with the proper instrumentation. And there used to be a program on the Discovery Channel which used to say man, moment, and machine. So you are the person. This observational moment is your moment, and machine definitely. Today is the world drifted away from that hanky panky zone of those very classical sort of those images where you will find one person observing through the telescope, looking into the cosmos, secluded from the world, and then making discoveries. No, today is the world of tabletop astronomy, where we are on to where the entire universe is on our table. There are different sky surveys that are going on. We can decipher the data on our own. You remember when Chandrayaan 2, whose crash landing happened, the Vikram lander crash landed, who discovered the debris of that Vikram lander? It was a person who was not into the field of the astronomy. So all the discoveries, all the detections, they really can be made by anyone. Why not you? The only thing is you have to bridge the gap between something which is known as public, which is non-seriousness, and science, which is seriousness, highly serious. So there has to be some bridging medium between the two, and you as a citizen scientist can work wonders. So we are now quickly going on through a cursory look, and I hope that I have not exceeded much of the time. I have spoken for about 12 minutes, so I will speak only 7 8 minutes more. So there are a few important projects which really can help you interact with the public, especially just wait, sorry, I hope I am audible to you all. Can you hear me?
Yes.
Sure.
Yes, yes.
Yes.
Sure. Thank you. So there are different ways in which we really can interact with the moon as a public person and interact to the pursuit of the scientific knowledge. So let us begin, because there is a famous saying, child is the father of the man. So let us begin with the age group of the children. So this is one of the projects which really can help the children contribute to the pursuit of science by becoming cultural astronomers. That is iSteam Moon Over Us Phases and Phases program, which aims at students primarily from the age group of 8 to 12 and 13 to 16 years, and even beyond, if they are there. You know what happens is, in this age of technology, somewhere down the line we have forgotten naked eye astronomy, or too much overdose of technology has done this. So what we try to do this, we try to blend naked eye astronomy and integrate it with technology in the modern trending field of STEAM. And as you can see, the explanation of this acronym of STEAM, This Moon over Earth project has got a blend of science, technology, engineering, arts, and mathematics. And here I have written astronomy specifically for A, because astronomy is a unique blend of art, craft, and science on its own. So at the right, you can see this is a beautiful picture drawn by one of the child who is from Beijing, and she has tried to observe the moon. And you will see, because of the pollution, the clarity of the moon is not so much as we are blessed in India, or in those, you can say, the African or the South Asian or Southeast Asian nations, where we really can see the moon with huge clarity because of less and lesser pollution. So let us utilize this opportunity and try to, you can say, seek oneness with the nature. So what we do is, in the methodology, participants, they are given a basic, you can say, before taking this project, they are given a survey. A few basics are being asked, and then what happens is, it is followed by naked eye plus the naked eye observation plus the observation via the mobile. And then the students, they are being asked from the different regions, from the different countries, to put it in their photographs of the images that they have taken with proper, you can say, documentation in the sense latitude, longitude, and all those parameters that are needed. Now you see one simple photograph of the moon, and when we try to make that student aware of all these features which you see in point number 3, time, date, latitude, longitude, you see how the basics of geography, or in fact the basics of positional astronomy, or in fact the basics of the cosmic sciences, the cosmology, they or space sciences, they are slowly inculcated into the students. And now what happens, we always see that, always mention that the seasons of the northern hemisphere and southern hemisphere, they are inverse. So how, what would be the phase of the moon? The moon will definitely also be opposite of each other. So what happens is, students, when of the northern hemisphere and the southern hemisphere, they tend to compare the photograph of the moon. Doesn't it develop curiosity? Yes, it does. And there it becomes the first step towards learning the field of astronomy as a citizen scientist. And when they become professional, they themselves don't know. Then of course it brings in the different historical beliefs from the point of view of the poetry. That is, we encourage all the kinds of this teamwork which really can be taken, and we do reward the students who undertake all these projects. So definitely, this is the building of a cultural astronomy. And these are the photographs that have been taken by the students. They are not of NASA and all those lunar phases which I have just written. It is just, I have tried to explain to you that what these phases are there. It is a theoretical thing that if you are in the southern hemisphere, it will happen, and all those things are there. It can be read, but I want you to concentrate at the bottom, the photographs at the bottom. Definitely, the first photograph is not the new moon, it is near the new moon, the day after. But these are the photographs that have been taken by the students, not by any, you can say, professional astronomer, or you can say a very high grade person. They are taken by the senior secondary and the secondary level students. And you see what they have done. They have not only taken the photographs, but they have learned the art of the processing, the craft of the art of taking photograph, the craft of processing, and the science behind all these phases of the moon. It can be beautifully dealt with. And all the facts of the moon which I just cited regarding the first quarter, the full moon, third quarter, and how much is the moon visible, 95%, and all those things, they really can be understood by visual observation. So this is how learning by doing and enjoying by learning. So citizen science has got a huge scope as far as the moon is concerned. So these are a few of these images that have been taken by the participatory students in this Moon over Us program. This is courtesy to Aditya Venkatesh, who did it from Dubai. And you see the landscape and the way the moon is there. Now this is one of those growing phases of the moon taken by very young students from simple mobile. And you see the progression, how the moon behaves. And you can see a sense of rotation also, that how the phase is progressing. This is the waxing phase of the moon. That is, moon is growing from a new moon to almost a full moon. You see how the phase is added after a certain interval of time. And so these are the different ways in which the students can express. See, the mode of the expression makes the science really grow into the field at the really very tender age. So this project really aims to look for. Now, if you go for a very sophisticated work can also be done in this similar sort of an activity. This was a project in the same moon over us. What the students did was they assembled a mosaic of the moon, of the different portions of the moon that were photographed, and then they tried to map that particular crater and find out the radii. And it was to a very fair accuracy that the students were able to map on the moon and scale it at the level of the moon. And the same sort of a crater activity at a very young age, it really can be, you can see the students doing from the kids who participated from Romania. And at this very tender age, it is not simply a kid throwing the stone over the earth, they are learning something which is known as impact. And what they are making is impact greater than if they are throwing stones at an oblique level or at a straight level. All these things, they really can be inculcated into the minds of the young people at a very tender age with such sort of citizen science project. So that is why. And then, of course, NASA's micro observatory, it does also have a very serious and a very sincere effort for you to learn about the moon, the features of the moon, process it, analyze the different feature with the help of its micro observatory and an online tool that's available free of cost, which is platform independent JS9 4L. So these are the different regions from which the people participated in one of these such projects from India specifically. And what it did was, today the students, they have become scientifically vigilant, and especially in the field of inquiry and data analysis, and many of them are trying to pursue, look for a career in the field of astronomy and astrophysics. So a simple moon over us, this simple throwing of the activity of the equator can result into the students dealing into the field of astronomy and astrophysics. So this impact of such sort of citizen science projects is very, very, very huge as far as moon is concerned, as far as the career is concerned. And this is one of the special cases in which we took it as an initiative of the Indian School of Deaf, Bharati Badri Vidyalaya, where the students, hearing and speaking impaired students, they were given an opportunity to learn under this project, and they are also associated at the moment with SS Citizen Science Group also. And the students, they did remarkably well, wonderfully well, and they have made an acclaim at the international level. So definitely all these citizen science projects, they can work wonders. And so what happens is, these sort of the images, all these things you can see, this is not a simple GIF image that is being done. This tells an entire story of the progression of the moon. So all these things, they really, really, I'm reiterating on the point that they are very much important for the inculcation of the scientific inquiry and the spirit of the science within the people at a very young age. And then, of course, there is a step ahead for the learners at the intermediate and the advanced level, that there is a facility which is known as Las Cumbres Observatory. And as a Global Sky partner, I handle an open hand invitation to you all to come and join us. We are a Global Sky partner as ICE team, and I, being one of the co-investigators, I invite you all to let us explore the moon, the different features of the moon, which I'm showing you a pilot project that we started, and now we are going to expand it from the month of August this year. So what we did was, our students, they got the opportunity to take a photograph from the 0.4-meter telescope of Las Cumbres Observatory, and with the help of kiosk, what we did was we developed a standard manual. And what was the result? This was the result. You see, on you can see these are not simply the photographs of the moon, but they are an entire story in itself. 15 days apart, moon on November 16 and moon on November 29, almost 15 days apart. How different is the behavior from the same place? You see, these are the 4 continuous days of the observation. Now you yourself can identify whether the moon is progressing, waxing or waning, and in which manner the progression is happening up. So this really can help you to understand the different subtle features of the moon in the scientific format as well. Now this is how a moon behaves almost a month apart. So all these features, pictures, they were taken by the students in the scientific grade file, which is known as FITS file, which is just like a format like we have images in the JPG and PNG. Similarly, we have got FITS images. So when this pilot project being very successful, I roll out an open invitation to all the attendees. Come and join us. Let us study the moon together with the help of 0.4-meter telescope as citizen scientists. So this is one of those things. And what next? After the moon, it really opens an entire Pandora's box for you. You can study galaxy, nebula, globular cluster, star cluster, everything can be there. and participants from all these different continents are right now participating with us, and they are learning astronomical data analysis techniques which are being used by professional astronomers. And these are a few of these images that have been taken and processed by our students of senior secondary and secondary level. So you see what all this simple photography of the moon, it started a brain wave. It is a chain reaction that happens into the minds of the students. And of course, coming to the closure, this definitely is one of the most cherished event. The top or the above one is a lunar eclipse simulation image, and the bottom one is the top one is that solar eclipse, and the bottom one is the lunar eclipse. And these eclipses, they are also a period of study for us if we want to sincerely observe the different subtle features with the help of moon or of the moon. Especially during the solar eclipse, you see, even though the eclipse is solar, but we really can do lunar limb profiling. And if you are an astronomy enthusiast, you really can enjoy this beautiful phenomena. These are the two images, that is the two composites that were taken of the lunar eclipse that happened in the year 2022, as well as the solar eclipse from Lucknow, and with due help from Uttar Pradesh Amateur Astronomers Club and Council of Science and Technology, UPCST, Uttar Pradesh. So you see, this simply is not a picture. You can see how the eclipse is progressing, and if you observe it from a very subtle instrument, you really can work wonders as far as the entire progression of this moon over the sun continues, or the shadow that engulfs the moon. You really can go and work on the different techniques of astronomy like photometry and everything, interferometry, everything can really be done if you are into the field of citizen science. And yes, of course, this entire lecture will be incomplete without showing you these two images taken by the one of those most brilliant of the persona that India has ever produced in the modern day of 21st century, Sri Soumyadeep Mukherjee ji. He, you can see how he has beautifully combined and studied the towards the left are the three composite pictures over spread over 3 months. The first one is the moon and the Venus. The second is occultation of the Venus by the moon. You see the different phenomena of the occultation and all those things, they really can be studied. And I was just telling you, the orbit of the moon is not simply, you can say, uniform around the earth. So this is the proof is really evident from the photograph on the right side. You see super moon and the micro moon, how much the diameters differ. And see, if all these things they can be done by Soumyadeep Mukherjee sir, then you can also really follow into the footsteps of people like Soumyadeep Mukherjee ji. And there are other photographers as professional as well as amateurs like Amoli Kakkar ji, and all who are associated with Shobhan Acharya sir. You really can join Shobhan ji, and you will get into touch with all these photographers, and you can hone your skills. And of course, you can also become an astronomy picture of the day. Your observation can also become an astronomy picture of the day for NASA. Best wishes. This is also a part of the citizen science as an astrophotographer. And with these words, I come to the end of my presentation, expressing sincere thanks to Bonnie Truber ma'am, Dr. Edward Gomez, LCO, Dr. Carlton Pennypacker, and all of the people who are there from India who supported me, especially Moon Over Us team, and my mentors like Bharat Adur sir, Narendra Bhandari ji, S.L. Sukumar ji, Chitra ma'am, Tushar Purohit ji, and Dr. Suresh Iyer. And last but most important, the members of the SS Citizen Science Group, Shri Shobhan Acharya, the convener, and the person who I always take inspiration from, Shri Soumyadeep Mukherjee ji. With these words, wishing you all a very happy International Moon Day, I arrest my presentation. Thank you. Thanks a lot. Thanks, organizers, for giving me this wonderful opportunity.